Hey, welcome back. In this video, I'm going to talk about functions in Ruby C API. Now, functions isn't the correct term here because Ruby is purely object-oriented programming language and Ruby doesn't have functions, but it has methods and method calls. But I have said functions because we are going to define C functions that will be called with a Ruby method, like this. So, without any further ado, let's get started with our good old terminal. And let's create a new directory called abcd and cd into abcd. And now we have nothing here. Let's create our xtconf.rb file and now require mkmf and create makefile. We are going to call it something different. We are going to call this mouse this time because we are missing mouse. And now let's define our C file. Let's call the C file as doc.c. We are going to include ruby.h and then we are going to define our good old init function, init mouse. So we are going to define our Ruby function in C. To do that, we need rb define global function and then we need to pass the function name. We are going to call it up. So we have to define this here. Let's call it value up and return something. If we return a string something here, this is a C string, but the function should return a value in Ruby. So here we are calling this value because it should return a Ruby value. And to do that, I have to call the rb str new cstr function. This will convert the something to a Ruby string and that will get returned as a Ruby value. And then we have to give some name to our function. Let's call it up. And when we call up here, it will call this C function here and that takes no argument. So we will write 0. So this is the Ruby method name and this is the C function name. And this is the number of arguments. So when we call up, it corresponds to this up here and this is get called and it returns something. If we compile and run our code, to compile we need to do ruby xtconf.rb ampersand make ampersand ruby -r because our file name is mouse, and then I'm going to call up here. As you can see, it returns something here. But if I edit the function now and call it maybe down, we need to change it here. Let's also rename this up to donkey. So if I call donkey here, you get something. So this is how you can create functions, but there's a caveat. In Ruby, you have to accept another argument called obj. You can call it anything, but you have to do something here. So we can call it maybe x. So if I return x, this is actually main in our case. For example, if I compile and run it, we get main back. Do keep in mind, whenever creating a function in C, you have to accept a value and which is the self value, and then you can have an n number of arguments. So let's call it y, and if I return y, it will return the next argument. In our case, there's no next argument, so we have to increment 0 to 1 because it accepts one argument. If I call it this way, you can see we have argument error, but if I say 5 here, it will return 5. If I give it an array here, it will return an array. It doesn't matter. If I do dot push on that array and push it 5 and 6 and maybe 10,000, we get 5, 6, 10,000 because it just returns this array. Now let's do something interesting here. So we have value x, which is the self object, and we have value y, which is the argument. If we do return y, we get the same object back. But let's check the type, and if we have a string, we will return 5 copies of that string. And if we have an integer, we will return the integer times 5. So we have to check the type of the argument. We can do that with rb type p, you know by now. And then we are going to check if y is a string or not. If it's a string, we are going to return rb func call, and then a, sorry, y here, I'm calling it a every time. Let's rename it to a, and get 5 copies of a. So this is not really fast because we have another function call here rather than a loop that iterates 5 times and gets 5 A's. But this is very simple. It accepts one argument, and let's multiply it with 5. So we don't have 5 here, so we have to do into fix 5. Now when we call it and give it a string, and we get back 5 copies of the string. Now if we don't have a string here, we will do else if rb type p a. Now check if it's an integer or not. T fixed num, and then equals to 1. If it's a fixed num, then we are going to return rb func call a rb intern times, and then 1 into fix 5. So we are going to multiply that number with 5, but we can also do that without calling this function here. We can return a, but a is a Ruby object here, so we need to convert it to C number. We can do num to ull, and then we are going to multiply that with 5, and then we are going to convert it into num, or maybe ull to num, and then we are going to return this. But this won't work with big numbers, for example, because in Ruby, I believe the implementation is done in GMP library, but we don't have anything here. So the ultimate range is whatever the ull to num is. For example, on my system, it will be 2 to the power 64 most likely. And then it is likely to be this big, and we can't have any number that is bigger than this because we have num to unsigned long here. If I comment this out and write our next else, we want to return the argument if it is neither a string or a fixed num. So we want to return whatever a has, right? So if we compile and run it again, as you can see, we get back the array here. But if I do 5, we get 25. If I do something like ABC, we get ABC, 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 ABC. If I do 25, I should get 125. If I do 1, I get 5 copies of 1 because it is string. We can also create string like this in Ruby if you don't know yet. So we get 5 copies of 1 here. So that's how you can create functions in Ruby-C API. Now let's do something very different. We are going to create a uppercase method on string with C. To do that, I will clear out doc.c file. As you can see, we have this. To clear out this file, we can just do this, and it is cleared out. Now we can run nano on this and include ruby.h. And then we also need something like string.h, and we also need ctype.h. This is actually default. You don't have to install anything to get these things here. So everything is inside the standard library. Now let's write our main code. So we are going to create a function called n, and we have to accept the first argument, which is the self. And then we are going to accept one argument called x. We have to now convert the x to a C string x. To do that, as you have seen in the previous video, we can do char star d. Let's call it star d. And then convert it to a string with string value ptr x. And this is a C string now. Now let's define an integer I equals to 0 for the counter. And then let's create a character n, and then allocate the length of d, and also create a variable called ch. Now let's loop over the string. And then we are going to convert and store the uppercase later inside in. We can use the toUpper function, which is coming from ctype.h. And we are going to convert the character to uppercase. We are storing it inside in. Now we also need to increment I by 1, and we have an array of string that is uppercased. Now we may also need a null character at the end of the string. To create a null character, you might know we need \0, and then we are going to return rb str new. Not cstr here. We are going to return n, and then the length of n, which is actually I. Now to call our function, we also need to define the void init mouse here, I believe, and then rb define global function. Let's do a global function now. Let's call it x. We are going to call in, which is this, and then it takes one argument, right? So let's test this code. Hopefully it works. As you can see, we have uppercased the ABC here. And now let's define this function on string. To define this on string, we need to actually create a class string here right now. So we will do rb string equals to, we can define classes like this, rb define class string, and then rb c object. And then we are going to define method on rb string, which is this here. And then let's call it uppercase2, and then it will call n, and it takes no arguments. So it takes no arguments, but here you can see that we have one argument. We have to remove this because it accepts none, right? So we have the obj here, which is a self object. When you write a Ruby class, you can see that you have to do class string and then def in, and then you do self.uppercase, and you can also call uppercase like that. Or you can also do this string.define method uppercase2, or maybe n2, whatever you want, and then you will do uppercase or self.uppercase. In C, we have the self here, which is obj, and then we are actually going to work on this. Instead of x, we have obj. You can call it self as well, I believe. And then we have this function. Now we can run string.uppercase2 to convert a lowercase character to uppercase. So if we compile and run this code, we have undefined method because we don't have this right now. So we can do pabcd.uppercase2. As you can see, we are getting capitalized ABCD, or maybe uppercased ABCD. And if we call uppercase like this, it is the same thing. Now, if you want to compare the time it takes to call this method, you can do this. We have to remove the p. We are going to assign a t called time. We are going to assign it to process. clock get time, and then we are going to pass process clock monotonic, and then call this method, and then we are going to differentiate between this time. Process clock get. We don't need scope resolution operator here because it is just a module function, or maybe a module method. Clock get time process clock monotonic, and then we are going to subtract that with t here. So if I run p here, you can see it takes very small time, but if I do this, create one character a and then multiply it with 10,000, it takes some more time. If we multiply it with maybe, as you can see, if we have a very big number, we get stack level to dip because we are passing this string as function. So we may have a string of this length, maybe it takes 0.002 second for this length string. But if I call uppercase here, the Ruby uppercase, it takes quite the same amount of time, right? Because it depends on the system. I have a screen recorder running, so it can fluctuate right now. If I call uppercase 2 again, it depends, right? So it is the same time. Now if we print this, so if I run puts here, you can see we are getting capitalized A out of downcased A. And if I have a capital A and remove the puts from here, you can see it takes quite similar amount of time. So that's it for today's video. I hope that you got how you can create a function in C and call that in Ruby. I do thank you for watching. Please like this video if you liked it, and dislike with a constructive criticism if you dislike this video. So thank you for watching. I hope to see you in the next video where we are going to cover arrays and hashes in Ruby C extension.